Okay, we're back this time with pairs of angles. So we'll start out by some definitions and then work some examples, and hopefully it won't take too long today, but we'll see how it goes. First of all, we'll talk about adjacent angles. The everyday usage of adjacent just means next to, and that's kind of what we have here, but let me give you a mathematical definition of adjacent angles. First of all, they're two angles in the same plane. And they have a common vertex. They have a common side. And no common interior points. So an example of two adjacent angles will be the following. So we got angle 1 here and angle 2 here. And so we would say angle 1 and angle 2 are adjacent angles. So notice they have a common side. The two angles have a common side. They both have a common vertex, but there's no common interior points. So there's adjacent angles. Next bit of vocab here would be a linear pair. A linear pair. That's simply two angles that add up to a straight angle. Two angles that add up to a straight angle. So I'll give you an example of a linear pair picture. So this would be, let's say, angle 3 right here, and this would be angle 4. We would say that angle 3 and angle 4 form a linear pair. Okay. Let's take a look at a drawing and then kind of talk about it in terms of our new definitions. So I guess we'll call this example 1. So here's some points on our drawing. There's point A, point E right there, point D, point C right here, and point B. All right, let's talk about the relationship between angle AEB and angle BED. So I'm going to highlight those so you can see those. So angle AEB is right there, and angle BED is right there. So if you look at those, they add up to a straight angle, so they are a linear pair. they're also adjacent, but they're a linear pair. All right, this time let's consider angle AEB and angle BEC. So let me highlight those. So again, we can have a look at those. So angle AEB, again, will be right here. And this time we got angle BEC right here. So they don't add up to a straight angle, so they're not a linear pair, but they are adjacent because they have a common side and a common vertex. And let's talk about another pair on the same diagram. So let's talk about angle DEC. And angle AEB. Okay, so let me highlight those. So angle DEC would be this one. There's DEC, and then AEB be right here. So they're not a linear pair. They don't add up to a straight angle, and they're not adjacent either, because even though they have a common vertex, they don't have a common side. So there's nothing special there between those two angles. Okay. All right, let's talk about some more definitions here. Complementary angles is next. You might have heard that word before. Complementary. Very simply, they're two angles that add up to 90 degrees. Two angles that add up to 90 degrees. And let's get one more definition in here before we look at some examples. Supplementary angles are two angles that add up to 180 degrees. Two angles that add to 180 degrees. So let me draw some angles up here and then we'll talk about them. So there's your definitions, so don't forget those. Okay, I'm going to draw up here three angles. That'll be angle B, and angle B will be 37 degrees. Next, we'll draw angle A. And angle A will be 53 degrees. And then finally, angle C will be 127 degrees. Okay, so if we look at these three angles, we can say that angle A and angle B are complementary, because if you check their measures, -- 37 degrees plus 53 degrees is 90 degrees, so they're complementary angles. And likewise, if we compare angle A and angle C, those two angles are supplementary. Because if you look at those two angles, you have 53 degrees and 127 degrees. Those add up to 180 degrees. And so that means they are supplementary. Okay, we'll do a couple examples. Actually, I got three examples, and then we get another definition. Okay, I think we're on example 2. If I misnumbered that you'll get over it. Okay, so here is angle M. It's 26.8 degrees. So let's say somebody wants to know what is the complement of angle M. Well, you'll just do 90 degrees minus 26.8 degrees. Just do a subtraction problem. Got decimals in there. That'd be 63.2 degrees. Right? Let's say we have this time for our next example, example 3. Angle N and it's 2y plus 20 degrees. So an expression this time, 2y plus 20 degrees. And someone says, give me the supplement of angle N. So the supplement of angle N is 180 minus that angle. So 180 minus 2y plus 20. And then you're going to just simplify that. So distribute your negative sign. So 180 minus 2y minus 20. So 160 minus 2y degrees. That'll be the supplement of angle N. And notice it's not a number, and you can't give a number because you don't know what N is. Actually, it's y, isn't it? Yeah, you don't know what y is, so therefore you can't calculate the measure of angle N. Okay, let's do another example, and then we'll talk about another definition. So example, whatever we're on, 4, I think. This one's a word problem, really. An angle measures, this will remind you of algebra. An angle measures 3 degrees less than twice the measure of its complement. Find the measure of its complement. Of course, if we find the angle first, we can just subtract that from 90 to get the complement. So there's more than one way to do this problem. But whatever you do, what you've got to do is define your variables so that you can tell your reader what your x stands for, whatever you want to use for your variables. So I'm going to say x is the angle we're talking about, measure of the angle to be more specific. And so that means that the complement would be 90 minus x. If an angle is x, we know the complement is the number which makes with that first angle adds up to 90. So we can just take 90 minus our angle. And that'll be the complement of the angle. Oops, I think I spelled that wrong. Okay, now we're going to set up an equation based on what you can read right up there. Okay, an angle measures, so an angle equals, so x equals 3 degrees less than twice the measure of the complement. So twice the measure of the complement would be 2 times 90 minus x. That's twice the measure of the complement. But that angle x is 3 degrees less than that, so we have to put a minus 3 on the end. Okay, so now we're going to go ahead and solve this equation. That'll give us the angle itself, and then, of course, we can just subtract from 90 to get the complement of that angle. So let's use our algebra skills here. So x equals 180 minus 2x minus 3. X equals, that'd be 177 minus 2x. Add 2x to both sides, so 3x equals 177. And divide by 3, so x equals 59. Okay, so we're not done then. So because remember, x stands for the angle. If you go back and reread the question, it says find the measure of the complement of the angle. So we actually have to go one more step and say, well, the complement is (180) minus that 59. So the complement then is 31 degrees. Okay, the last definition we have today then is vertical angles. These are so easy to understand, but I've seen people go almost the whole year without really knowing what vertical angles are. So let's get this straight. Vertical angles very simply are if you have 2 lines across, like this, 2 lines that intersect. You can see that we have several angles formed here. So we have angle 1, angle 2, angle 3, and angle 4. The vertical angles are angles that are across from one another. So in this diagram, we have 2 sets of vertical angles. Angle 1 and angle 3 are vertical angles. You can see right here, they're right across from each other when 2 lines intersect. And then another pair of vertical angles is angle 2 and angle 4. You see right there that they're right across from each other. So those are vertical angles. Okay, so for my last example, and then that'll wrap up the notes, I'll draw another pair of intersecting lines and we'll find the vertical angles. Okay, let's say that we have these 2, I don't know the example number we're on, maybe we're on 5, I don't know, 6, doesn't matter. Okay, we've got a couple of lines that intersect there. So you got some vertical angles. So they meet at point D. And here we got E and H on this first line right here. And then G and F on the other line. And so, by the way, notice that one thing about these vertical angles, and this is actually a theorem that we can prove. It's not a postulate, it's a theorem. We haven't talked about theorems yet. But these 2 angles right here, which I've just highlighted, those are vertical angles, and they look like they're congruent, and they are. So we're going to say angle EDF F and angle GDH are vertical angles because they're across from each other. And as we're going to see later, vertical angles are congruent. That's going to be, I think, your first theorem of the year. But then also notice that we got this pair of angles right here. They also look like they're congruent. And again, it's a provable theorem that they are. But we're going to write that out. So angle EDG, EDG, and angle FDH are also vertical angles. So two pairs there. Okay, so that's it, except let me do a quick summary here. So we talked about adjacent angles that are next to each other with a common vertex and a common side. Also, linear pair is just two angles that add up to 180 or a straight angle. We had complementary angles, which are two angles that add up to 90 degrees. We had supplementary angles, which are two angles that add up to 180 degrees. We saw some examples of all that. And then we ended up with vertical angles, which you can see on the screen now, which are formed when two lines cross. You got two pairs of vertical angles. They're simply the angles that are across from one another. And we'll see later that vertical angles are congruent. All right, that wraps up the notes. Enjoy.